it says, for 0 is less than or equal to t is less than or equal to 31, the rate of change of the number of mosquitoes on tropical island at time t days is modeled by this equation. So t is the number of days, this is the rate of change. So the y coordinate is the rate of, r stands for rate of change. And it equals 5 times the square root of t times the cosine of t over 5 mosquitoes per day. So it's there. This graph is a rate graph. It's gonna when you go to your calculator and you type in like 6 days, put in 6 for time, the answer that you get for y is going to be in mosquitoes per day. There are 1,000 mosquitoes on tropical island at t equal 0. Show that the number of mosquitoes is increasing at time t equals 6. So what I'd like you to do is go to your y equals, type in this equation. 5 square root of t times the cosine of t over 5. And then try to graph it on the domain 0 to 31. That's how I've typed in. 5 times the square root of x times the cosine of x over 5. So x is number of days. Then go to window. What should I set my x min in? What did it say was the minimum number for t? 0. How about the max? 31, wasn't it? So 31 for max. And then hit zoom 0. Zoom fit. There's our graph. Now the question is at 6 days. If I hit trace, 6, enter. It's given me this point. It says that x equals 6, y equals 4.437958. So what does that tell me about the number of mosquitoes on the island? Does that mean there's only 4 mosquitoes on the island?
There's 4,000?
I'm hearing some good guesses, but I haven't heard the right one yet, I don't think.
Rate of change, yeah.
Rate of change. So if this is the rate of change, what does that mean?
It increases by 4 every day.
Yeah, there you go. So on the 6th day, the amount of mosquitoes on the island is going up by 4.4379 mosquitoes per day. So it's increasing by about 4 mosquitoes a day. That's how fast it's increasing. Now that might seem confusing because we see negative slope here. Okay? Negative slope, though, means something different. And that's what the next question is. The next question, I'm going to move my calculator just for a second, says, at time t equals 6, the number of mosquitoes increases. Is the number of mosquitoes increasing at an increasing rate, or the number of mosquitoes increasing at a decreasing rate? Give a reason for your answer. So, the number of mosquitoes is definitely increasing by about 5 mosquitoes per day. Was it increasing at an increasing rate or increasing at a decreasing rate? What do you think?
Increasing at a decrease.
Right, it's increasing because this is a positive number, but the rate is decreasing. Let me show you. For example, let's say right now it's increasing at 4.4, about 4.4 mosquitoes per day. But if I go to the 7th day, trace 7, enter, I get 2.2. So on the 7th day, it's only increasing at 2.2 mosquitoes per day. So the amount of mosquitoes is still increasing, but it's increasing at a decreasing rate. Any questions about that? Let's go to like 12 days. Hit trace 12 in. So now it's negative 12.77. So what does that tell us about the mosquitoes on the island?
Nice.
Dying how fast?
Like 12 a day.
Yeah, about 12 a day. About the amount of, at least, there might still be mosquitoes being born, and there's also some probably dying, but the overall change in mosquitoes on the 12th day, the number of mosquitoes on the island in total is decreasing at about 12.77 mosquitoes per day. Now, the other thing I want to get to is, what about, can you move this for me so you can see? I want to show this over here. Here's my graph. Or something like this. What if I thought about the area right in here? I wanted to find this little area of, let's say, just a rectangle in there. If the height is in mosquitoes per day, and the width is in days, when you find area, you multiply the height times the width, right? Length times width. So if you would multiply mosquitoes per day times days, what do you think the area is going to represent? Mosquitoes, yeah, because these would cancel out. So the area is going to represent mosquitoes. Okay? So go ahead and put it back up on this again. I'm going to show you something new today that I haven't shown you before. Push second trace. And we're going to go to number 7. It's called an integral or an antiderivative. And let's go from 0 to 6. So 0, enter, 6, enter. And it comes out to about almost 35 mosquitoes. So this area represents 35 mosquitoes. So the original problem said that at time 0 there was 1,000 mosquitoes on the island. After 6 days, how many mosquitoes are on the island? 1,000, yeah, about 1,035, because this is almost 35. So this area actually tells you the change in the number of mosquitoes. Okay, between the 0 and the 6 days, the island gained almost 35 mosquitoes. Let's let's get rid of that shading by pushing y equals. Get on top of your equal sign, push enter twice. Then hit graph again. What that does is turns the equation off and back on again, and it gets rid of that shading for you. Now let's hit second trace. Whoops, I messed up there. Second trace, number 7, which is called an integral. And let's go from 8 to 12 days. So 8, enter, 12, enter. And that gives me an area of negative 26.3. Well, you really can't have a negative area, but what do you think that negative represents here? Right. Between the 8th and 12th day, the number of mosquitoes on the island went down by about 26 mosquitoes. Okay. Now let's do the integral from 0 to 30 days. So second trace, we don't really need to shut it off this time. Second trace, number 7, 0, enter, 30, enter. What I'm showing you is a little bit of what's called integral calculus. There's 2 branches of calculus we're going to study a lot. Differential calculus, which is what the first half of the class is, and then integral calculus. So I'm showing you a little bit of what's coming later in the course. This is not something I'll be testing you on in the next couple tests, but whoops. So this is giving me, whoa, I'm on the computer, negative 63. So here the island was gaining mosquitoes. It gained however many mosquitoes this area is. Down here, below the x-axis, it's losing mosquitoes. Here it's gaining again. But in the end, if we started with 1,000 mosquitoes. My pen's about down here. We started with 1,000 mosquitoes. In the course of 30 days, we have a net change of about negative 63. So after 30 days, there would be about 937 mosquitoes left on the island. All right, any questions about that? Go ahead.
On day 12, was it decreasing at an increasing rate then?
Day 12 is right here.
Yeah.
I would say it's decreasing. Yes, I would say it's decreasing at an increasing rate because, well, I don't know if I want to get into that because it's decreasing faster and faster, isn't it? Because like maybe here it's decreasing by 10 mosquitoes a day, and maybe here it's decreasing at 20 mosquitoes per day. So it's decreasing faster and faster, but the actual velocity would be getting lower. I would say it's decreasing at an increasing rate there. I think you're right. Okay, that's getting into even a little bit more tough, a little bit tougher question. But now, some of you have taken physics, right? Have you guys ever studied displacement? That's what this is right here. This is the displacement of the number of mosquitoes. It's the net change in the number of mosquitoes. Okay, let me turn that off, Alan. Thanks. Okay, let's move on. I just wanted to